Okay, so our equation, our parent function for sine and cosine are y is equal to a sine of b x minus or plus c plus d. Okay, now that we have that, let's draw our period. So let's draw our midline. So the highest and lowest point are at 1 and -5, meaning the period will be 3 up or 3 down. So 1, 2, 3. I mean our midline. So that's our midline. Our midline is at -2, which also tells us our d value. So our d value is at -2. Now to figure out the amplitude, we figure out the distance from one of the peaks or the bottoms. So 1, 2, 3, meaning our a value or our amplitude is 3. Now to figure out our b value, we first have to figure out our period. So our period for a sine graph, which starts from the x-axis, so our new x-axis, which is at y is equal to -2. That's our new x-axis for now. So it goes from there. So it starts right there. We draw a box there, and it goes to right there, because that's where our graph crosses -2. Now, to figure out our period, we do the difference between the x's of these 2 points, so this point and this point, and that will be 16 pi over 4 or 4 pi. That's our period, but that's not our b value. Our b value can be derived from our equation 2 pi over b is equal to 4 pi, meaning b is equal to 1/2. Now that we have that, all we're missing is our phase shift. So our phase shift is from this point, which was our original point, so right here, but then we moved down 2, and now we have moved to the right, pi over 4, then we go 2 pi over 4, 3 pi over 4, 4 pi over 4, and then 5 pi over 4. 5 pi over 4. So our first equation will be 3 sine. So let's put that in. 3 sine of, let's see, our b value is 1/2 x minus c. So 5, because we're moving to the right, we always put the opposite, and then we do one more parentheses minus 2. Now we do cosine. So for our cosine, let me just delete all of this and all of this. We do this, and then we put this right here is our cosine. Cosine parent function or cosine transformations look like this. So a is still our amplitude, but this time it's gonna be our cosine starts from a high point and goes to another. So our cosine graphs, our original cosine graph starts from 1, goes down, then goes up. So like that, right? But since there are transformations on here, we're gonna select a period and first let's do our midpoint or our midline. So our midline is still gonna be the same. It's gonna be at -2, so our d value is still gonna be -2. And then let's figure it out. Let's see. So our cosine, so where it looks like cosine is either here or here. But since we don't have a full period on this side, let's draw our period from this point right here to this point right here. That's one period. And from there, we also know our amplitude, which is from -2, how much up or down it goes. So 1, 2, 3. So 3 from the, so that's our amplitude. Then we have our period. So our period is equal to 2 pi over b. So our period in this case go from negative 7 pi over 4 to 9 pi over 4, which is 16 pi over 4 or 4 pi, meaning our period again is 1/2. Now our phase shift, on the other hand, since it starts from 1, it goes till right here, meaning it goes 7 pi over 4. That's our phase shift. So our new equation can be written as 3 cosine of 1/2 x plus, because we're going to the left, plus 7 pi over 4. 7 pi over 4 minus 2. And those are our two equations. Okay, now we have to graph the tangent graph and the cotangent graph. So to graph the tangent graph, first we have to figure out our midline again. So our midline is the line at our y-intercept. So it's this. So because our y-intercept is 0, 2, that is our midline, meaning our d value is 2. So let me write my parent equation, or just how I'm going to tan of b of x plus or minus c plus d. So now we have our d, right? Now, first let me graph our asymptotes. So our asymptotes are at pi over 6 and pi over 2. Right? Now to figure out our, let's say we're trying to figure out our period. So our period is going to start from 0, then go all the way here, and then the graph's just repeating because we have, again, this. So it goes from 0 to pi over 3, which is just pi over 3. Now to find our b value, we're going to plug it into the formula. Pi over 3 is equal to pi over b. Because in our normal tangent graph, our period is pi and not 2 pi. So this comes out, b is equal to 3. We have b. Now to figure out c, we know that there is no phase shift because our value at 0, 0 has just gone up 2 and not to the right or to the left. So there is no phase shift. But now let's figure out our vertical stretch, or vertical stretch or vertical compression. So to do that, we go from the asymptote to the midpoint between right here. So this right here, so this is our period, right? This box, let me draw a box around our period. So we draw a box around our period, and now we have five points. So now we go between the point, which is between the asymptotes. So like the point which is 1 and 1. So this point right here, and if we're going to the other side, there'll be 1 and 1. So this point right here. And now we figure out where it crosses the graph. So it crosses the graph 1 above the midline, and it crosses the graph 1 below the midline, meaning our a value is just 1. So our graph for tangent will be y is equal to tan of 3x plus 2. And there you go. Okay, so our function for our cotangent is y is equal to a cot b x plus or minus c plus d. Okay, so our a value in this case we figure out. So first we know that our asymptote in a normal cotangent graph is the y-axis, right? Is the y-axis right there. So if it's the y-axis right here, and in this graph, it's not the y-axis. It has moved to the right 6, meaning we have a phase shift to, I mean, not right 6, right pi over 6. So we have a phase shift of pi over 6. Now our a value is going to be from our midline, which still stays at our y-intercept, and it's still 2, to the middle value. Okay, so first let's find our period. Our period is right here. I'm drawing a box. This is my box from pi over 6, from negative pi over 6 to positive pi over 6, which is pi over 3. So pi over 3 is equal to our period, and then we use the same formula, pi over b is equal to period, or pi over 3 in this case, to get our b value, which is 3. Now that we have our b value, our c value, we can figure out our d value and our a value. So our a value is still going to be from our midline, and then we go from the asymptote right here and the asymptote right here to the middle points, and we go where it connects to the graph. It connects to the graph right here. And how far is that from the midline? It is 1 away. And let's check again. So from our asymptote to our midline, and then we go up, it connects right here, and how far it is, it's 1 away, meaning our a value is also 1. Now we have our a value, our c value, our b value. Now to find our d value, that's just our midline, so that's equal to 2. So y is equal to negative, and also our a value is going to be a negative because a cotangent graph is usually like this, but this time it's like this, meaning it's flipped over the asymptotes, meaning it's negative cotangent of 3x plus pi x minus pi over 6. I don't think that should make a difference. Minus pi over 6 plus 2. There you go. Okay, so one small correction on the cotangent graph is that I thought that this would be a negative, but this is a positive because this graph has moved to the left instead of the right, because this point right here has moved from the right to the left. So it's a positive instead of a negative. Okay, so let's graph our secant function. Now to graph our secant function, first let's write our equation. Y is equal to a secant of bx plus or minus c plus d. Okay, so now we know that to find a, we first figure out the distance from one of the minimums to one of the maximums. So that is 1, 2, 3, 4, and then take the midline and then figure out how much, and so that's going to be 2. So a is equal to 2. A is equal to 2. Okay. Now to figure out our period, we go from where one of the minimums right here and right here, and so it goes from right here to right here, which is 4 pi. So our period is 4 pi. Our period is 4 pi. Now to find our b, we use the equation 2 pi over b is equal to 4 pi, because that's what cosecant and secant use, and then we get b is equal to 1/2. We have b, we have a. Now to figure out our d, we just look at our midline, which is at -1. D is equal to -1. Now, we do have a phase shift, but in this case it is easy because this point right here, in like the parent function, it lies right here, meaning the graph has moved to the right pi over 3, meaning c is equal to pi over 3, and we have our graph. Y is equal to a, which is 2, secant 1/2 x minus pi over 3 plus, minus 1. And that's our secant graph. Okay, so I just figured this out. So I think the asymptote is not pi over 2, but instead it's something over 3. So this right here is negative pi over 3. That's why the phase shift is negative pi over 3. Now do our cosecant function. We do y is equal to, and everything stays the same because everything else is calculated similarly. So the 2 right here is still going to be 2 from the midline, and then cosecant and 1/2 is going to be still 1/2 because the period stays the same, and then the formula to calculate b value stays the same. Now our phase shift is going to be different because we had different asymptotes. And then up and down still stays the same because our midline stays the same. Now to figure out our period here, usually our period for a cosecant graph lies on pi, but it has moved to the left pi over 3 and one more pi over 3, meaning it has moved to the left 2 pi over 3, meaning 2 pi plus 2 pi over 3 because it's moved to the left.